Hello everybody, let's start the presentation about the paper. The paper is Automatic Based Symbolic Strain Analysis for Vulnerability Detection. The members of our group are Bryan Tabares, Jose Pinto, and Jairo Gonzales. So, let's start it.
The abstract. It is important to verify the application that manipulate change because manipulating them in another system will causes computer security problems. We present an automated-based approach to the symbolic analysis of string manipulation programs. We use deterministic finite automata to represent possible values of the string variables. Using the forward accessibility analysis, we calculate an over approximation of all possible values that the chain variables can take at each point of the program. The intersection of these with given an attack pattern produce the potential attack chain if the program is vulnerability. Based on the techniques present, we have implemented Stranger, a string analysis tool based on automata to detect security vulnerabilities related to string in PHP application.
So, in this paper, we focus on vulnerabilities related to string manipulation, and we propose a string analysis technique that identifies if a web application is vulnerability to the types of the attack we discussed about.
An overview. In this section, I will briefly explain the application of the disinfection routines commonly used in the web page and the vulnerabilities by analyzing simple PHP scripts. This script was taken from a web application called My Easy Market. In the next slide, what the script does per line is explained. And the goal of the script was to remove all the characters that should not appear in URL. The implemented script is the original characters that do not match the characters of the regular expression. And what is expression? This expression. Okay. This is the legibility other than alphanumeric characters and the ASCII symbols. However, the regular expression is not correct. And the ASCII symbols, this part. This early vulnerability caused the symbol can be used to start a script to launch an XS attack. Therefore, the disinfection operation can now remove the symbols from the underlying that vulnerability. In this diapositive, explain of the script. Siguiente, next slide. How is this vulnerability automatically detected? First of all, an analysis made in which of the dependencies graph the part of the script is analyzed. This analysis goes hand in hand with the forward reachability analysis, in which the result of the analysis is shown below each node in a forward reachability analysis as regular expression. Next slide. And the data dependency graph is applied to the script that contains the vulnerability in which nodes, a circular nodes, indicates a chain of operation. This circular nodes. This. Okay. Specifically, we focus on two chains operation, concatenation and substitution. Below each node, the result of the forward accessibility analysis is shown as a regular expression. In the forward reachability analysis, as possible values that each string expression in the program can take are calculated. In the dependency graph, it is started that the intersection of the result of analysis is covered. If an end of intersection is empty, then the program is not vulnerability with respect to the given attack pattern. However, in the example, the intersection of the attack pattern and results of the direct analysis for receiving node is not empiric, and these characters be the full regular expression, which means that there are vulnerabilities in this script. This part, in this part, the regular expression. Next slide. Next slide. Okay. In the second script, we present a simple routine that literally adds a query results to variable. If the date dependency graph intersection of the previous attack pattern is performed and this result is empiric. That is, given the values of the database, the code start terminal on the line 7 will not take any input that matches the attack pattern. We conclude that the segment is not vulnerability with respect to the attack pattern. This is a key example to understand a little more the presentation in the next parts. Next slide. In this diapositive, explanation of the script too. Next slide.
Sorry for the audio. In this part, it was lost. Okay, the automata based string analysis. For this paper, the automata needs be represented as a symbolic form. In this case, they use the Mona library that represent the automata as binary decision diagram and the data dependency graph to represent the data flow in the PHP programs files. Okay, the paper used two algorithms. The algorithm one that represents the vulnerability analysis that has as central the dependency graph as G and the attack pattern as M attack. And the second algorithm that represents forward analysis that create the post vector of automatas from nodes of the dependency graph. Algorithm 1, bool analysis. It initializes the post vector, set the var bool as 0, and starts the second algorithm for analysis, sending G and post. For each node of the dependency graph, it's trying to find see if the node intersects with the attack pattern. If the reach attack is different of 0, it will save the bool encounter. At the end, if the bool is different to 0, it will list each vulnerability and its direction and return vulnerable. In other case, it will return if the algorithm is secure. Algorithm 2, forward analysis. It will start a kernel of the root of the dependency graph and analyze each node of the dependency graph until it reach the fixed point. If the node is an input constant variable or null, it will create an automata of the node. If the node is a concat, it will create an automata with the last two automatas. If the node is a replace, it will create an automata with the three last automatas. At the end, it will save all the automatas in the post vector.
Okay, this is the part of Strange. Strange takes a PHP program and an attack partner characterizing XXX as a cool injection or malicious file execution. As input and output the possible vulnerabilities with respect to the attack partner. So the archetype of the stranger is shown in the following figure. Well, the first step in our analysis is to parse the PHP program and construct the control flow graphs. The control flow graphs is passed to the time analyzer in which data dependencies analyses are performed to generate the data dependency graph. The strange analysis implements vulnerability analysis on the time dependencies So the graphs found by the time analysis. Then uh, and then this part of the automata, sorry, and the automata-based string manipulation library, uh, they are in this. In this part are realized many operations with result executes to generate an automata. When the automata generate pass at this part with each monad package, and we execute this part, they generate the binary sorry generate the binary decision diagram. So this is the part of the stranger.
Sorry for the audio. In this part, it was lost. Experiments. They use Intel machine with 3 GHz of processor, 4 GB of RAM, and Ubuntu Linux. They simplify 4 web applications: My Easy Market, PL Boot, Westbooks, Blockit, and Pro Manager. Stranger generates a dependency graph of the 4 programs. The nodes and the edge of the dependency graph, the sinks, the vulnerability functions, the inputs by the user, and the literals, the sum of the constant string in the dependency graph. The performance, the time execution by the forward analysis and the total of the analysis, and the memory usage. The string manipulating functions, the number of the concat and replete operations in each program, and the time that it takes to run. Deterministic automatas generated by a stranger. The number of states by the normal deterministic automata and the number of nodes of the binary decision diagram representation. The next step to detecting XSS vulnerability in web application is select 8 programs that they didn't manually simplified, and they record the number of PHP files and the number of sinks and total log. The attack pattern is sigma asterisk minus script sigma asterisk for detecting XSS vulnerabilities. They register the number of vulnerabilities by string analysis and time analysis, and the total time that the string analysis take for forward and total, the memory average, and the CC nodes, that is the cyclic dependency in the dependency graph. The last table represents the inserted estimates of the sanitization protocols to decrease the string analysis vulnerabilities and the time that the analysis take with this estimate inserted. The present paper was possible thanks to the people that worked in string analysis that the present list. Conclusions. The first one is development tool is useful to find unknown and known vulnerabilities in web applications. The second one is the extension of the work is to create a patch and modify malicious entries to prevent the potential security exploits. And the third one is the use the non-deterministic automatas because the deterministic automatas is known as has a state expression during the determination.
Thank you very much.